This conference will now be recorded.
And I think we can get started. So thank you all for joining. This is, I believe, our third or fourth meeting for the DCF Sustainability Monthly Call. Some of the general topics that I wanted to discuss was the OCP conference or summit in Prague. That was the regional summit. And that happened after 2 years. So it was the first one after COVID that was in person. I believe the previous ones were virtual. So it was really nice seeing people in person, talking to people, meeting people. We have a lot of folks that I met at the conference that are here on the call today. So thank you all for joining. And hopefully we'll get you to participate in some of the working groups that we have going on as well. In the meeting notes, I have put in a link to the group IO page. If anybody is interested in participating, and I'm going to share that in the chat, but if anybody's interested in participating, please ask them to sign up to the group IO page, and then they will and subscribe to the calendar invite. So that can be pretty tricky because even if you sign up to the group IO page, you won't be able to, you won't get the meeting invites on your calendar. So you'll have to subscribe to the calendar page as well. And I'm going to paste the link to the calendar. It's also in our meeting notes, so you should be able to access that off of our wiki. So please go in and subscribe to the calendar so that you get all the meetings. If you go in and look at the calendar, it's been populated with this meeting and then all of the workstream meetings. So you should see a monthly meeting for the water, heat, energy workstream. You should see a monthly meeting for the metrics workstream, and you should see a monthly meeting for the construction emissions reduction workstream. So do you have any questions regarding that before we move on? So see Aaron and Robert on the call today. So Aaron, did you want to give us a brief update on the water, heat, energy work stream, what you're planning on doing, and when your call is scheduled, etc.?
Sure. So hi everybody, I'm Aaron Wimhoff from Villanova, and so I volunteered to head up the work stream on energy and water, and energy, water, and carbon. And essentially, we've had just a couple of conversations at this point, just ramping up. The idea behind it is we're just looking at the interplay between energy, water, and carbon, and doing some quick calculations to look at some metrics as to how, to illustrate that interplay. Our first official meeting, we'll say, is going to be on Thursday, the 25th at 10 a.m. Pacific or 1 p.m. Eastern. So if you're interested, I encourage you to come out and we can talk about it. I've had a couple of folks already that are on board and some others that have expressed interest that I've been talking with. And so the document's already been started, and we hope to continue to grow it and turn it into something very nice for the San Jose meeting.
Great.
Thank you, Aaron. I appreciate that. Any questions? Robert, did you want to give an update for the metrics?
Sure. Yeah. Am I coming through? Okay. Yeah.
Yes.
Rob Bunger, Schneider Electric. I was volunteered, I think, by Cosmo to help out with the metrics. But I do have a little bit of history with regards to the OCP Ready program and Mark Dancing. So I think the idea, which we haven't started work yet on this, the first meeting will be, I think, the same week, the week of the 20th, is to look at which sustainability metrics would apply and how would we integrate those into the OCP Ready program, and potentially even look at what targets should we be looking at. So we should have actually a reasonably good starting point with regards to the metrics to be considered. But it should be good. I think it'll help beef up the OCP Ready program.
Thanks, Robert, and nice to have you on the call. And thank you for for accepting the recommendation to head up the group. So we appreciate that.
No,
I'm looking forward to the product.
yeah, thank you.
And so just something for you to be aware of, there is a top level sustainability initiative work group as well. And they look at more of the IT side. So part of the metrics as well would incorporate the IT side as well. So just something for you to be aware of, Robert, as we move forward. I see you dropped off and joined again. Did
Yeah,
you get
something
that?
happened there. Could you repeat that? All I heard was to be aware of on the IT side.
Yeah, the sustainability initiative, which looks at more on the compute and IT side of sustainability, had a recommendation to start up a metrics group as well. But we want to provide one combined OCP position paper on metrics. And
Oh,
so we were going to join forces and have them join this group as well. So look out for someone reaching out to you. I think Alex Racal was going to make that connection, and you
okay,
should just look out for that and make sure that we include them in the development of the paper as well.
perfect. Okay, thank you.
Okay, great. Do we have Steven on the line? I know she was sick. I don't see her. Okay, so Steven's heading up the construction emissions reduction working group. She was sick, so the meeting this week was canceled. But we will try and reschedule that so that we can at least have a first meeting this month when she's better enough to lead that meeting. So look out for that announcement as well. This working group would be focused more on scope 3 emissions reduction on the facility side. So I think that's going to be quite interesting because it's a topic of interest for a lot of us. So one last announcement, and I know I have a lot of you on the call who may be interested, but there will be a sustainability Tech Talk series at the Intel location in July this year. They're still finalizing on a date in July. I think it's going to be around hang on a sec, I'll look at my calendar. It's going to be around the 24th and 25th of July. So, and the location will be in Seattle. So, sorry, Seattle or Oregon. I'm not really sure. But I will let you know. But we are looking for speakers for that conference. I was thinking we should potentially have representatives from each one of our work streams speaking. And then also, scope 3 emissions. I see Zach on the line. Zach, if you wanted to do a prezzo on concrete emissions reduction, that's something we could consider as well. So I need speakers finalized at least by this week. We're looking for 4 speakers from this group. So if you're interested, please feel free to reach out to me. Robert, your talk's already included as part of the overall sustainability initiative talk. So I know I saw your name on that list, and I'm sure Alex will be reaching out to you about that as well. So
All right, good to know. Good to know. Thanks. Yeah.
just a heads up for you. So don't volunteer for this one unless you have something else you wanted to talk about. We'll be more than glad to have you.
Sounds good. Thanks.
So please reach out to me. Let me know if you're interested, and I will make sure that we pen your name for that Tech Talk series. Aaron, you might want to present some of your existing papers that you've already written. That's always welcome. So think about it. Let me know.
Sure. Can you please send details when you get it?
Sure, absolutely.
Great, thanks.
So there was a recent hyperscale call to action that was published on the ICA, which is the iMasons Climate Accord website. I'm not sure if a lot of you saw that, but if you are interested, take a look. I pasted the link in our chat. And if your companies are interested in signing up and joining forces to support the transition to greener concrete for data centers, please sign up or get your company representatives to sign up for that as well. Okay, any questions or open discussion before we hand over the floor to Wholesome? Okay, let's open up the floor to Wholesome. So Zach Lovett is from Wholesome, and he will be discussing the decarbonization of concrete. Zach?
Yeah, thank you, everybody. Appreciate the opportunity to speak today. I know that this presentation is heavily focused on what Wholesome is doing, but before we get started, I just want to point out that I think that everything we're doing as a company is possible for any other cement or concrete producer. We are vertically integrated in many markets in the US and globally where we have cement and concrete production facilities. But you know, I think that what we're going to show today is something that we certainly hope the industry as a whole will follow. Wholesome is a Swiss-based company. We're the largest producer of cement on the planet right now, and we feel that it's our responsibility to lead the movement towards lower carbon concrete materials. So again, I know it's heavily focused on what we're doing as a company, but in a commoditized business such as ours, we're really not allowed to speak to our competitors to kind of compare notes. So I can only really speak to what we're doing, but I do think it shows what's possible within the greater industry as long as we're all kind of working towards the same goals. And when I say we all, I also include government in that. I include
Is this audio working?
Yeah, I think he dropped off.
Okay.
and it's not letting me, there we go. Okay.
You're back.
So being that Wholesome is a Swiss-based, European-based company, we signed on to the Science-Based Target Initiative in Europe, which affected our operations globally. The commitments that we made weren't limited to Europe, but you know, they do affect us. By signing on to that Science-Based Target Initiative, we pledged to reduce our carbon emissions on a global scale, not just in Europe, where we have a very large footprint. So this just kind of gives you an idea of where we're going, and what this is showing is specific to cement production, because ultimately, as you'll see later in the presentation, cement is the biggest challenge we have ahead of us. You know, we also produce asphalt, concrete, and ultimately the stone that goes into those products through quarries and sand and gravel pits. That is a very small part of the challenge that we have in reducing our carbon footprint. So what this is showing is where we are targeting going as a company per ton, or metric ton, of course, of CO2. And it kind of shows you, that's your kilograms of CO2 per metric ton, sorry. But it shows you what we are trying to do by 2030, and then obviously we get much more aggressive beyond that. What I would also kind of point out here is that it's really 2030 is when we begin to look at carbon capture and storage projects. Those are much longer term, much more capital intensive, and something that a company such as ours, and I would be willing to guess all of our competitors as well, really just can't do on their own. It's far too costly, and what we do with that captured carbon is a challenge that I think that we have to face as a human population, not just as a cement or any other manufacturing process. So just because I'm not sure the level of knowledge on the call, this is kind of a really good visualization of where the CO2 comes from through our cement manufacturing process. So the primary ingredients that we have traditionally used are limestone, silica, alumina, and gypsum. We mine those generally right next to your cement facility. We then heat those materials to around 2000 degrees Celsius. During that temperature addition, there's a large amount of CO2 that's released. There's also an incredible amount of energy that is required to heat our kilns and keep them running. So that's another large emitter of CO2 for us. Then it's shipped off to the finished cement is shipped off to concrete ready mix production facilities. Again, where it's mixed with water, stone, admixtures. We can measure that CO2 as well. And then what we kind of call scope 3, the transportation to the job site, to your job sites, the production of whatever it is you're building, in this case, obviously data centers, your use, and then end life. One of the things that I just kind of want to point out here is that end life, there's a note there that says concrete can be ground up at the end of its useful life to make aggregate for new concrete. That is true. However, one of the things that excites us is most of that crushed concrete, what we do is we take the stone out of it and we use it to make new concrete, or just use it as base material under roads or something along those lines. However, there's also a large amount of very fine material that is generated when you crush concrete. What we have been doing along with other cement manufacturers is trying to reintroduce that material back into our manufacturing process, because what we find is that there's a very good amount of material that never properly got hydrated, so it still has some cementitious value. We can reuse that material, and it's not easy, but again, it's one way that we can kind of create a circularity in that end of life process for any structure that we build. So like I was saying, if you look at what we call it, the decarbonation process, when we heat the raw materials, that roughly accounts for 47% of the emissions out of any cement manufacturing facility. 25% roughly comes from the fuels that we use to heat our kilns. So I think what the point of this slide to me is that even if, and believe me, we are all investing heavily in renewable energy. I'm actually at a cement facility in Maryland right now, where we've installed a solar array that is generating, I think, around 15 to 20% of the power that we use. So those are all very good activities, but ultimately, even if we were on completely renewable energy, 47% of it is still, of the CO2 we generate, is still coming from that release during the decarbonation process. And that's where the longer term challenge really is for us as an industry. So here's a few of these are the kind of the 4 buckets that our decarbonation teams have in their wheelhouse. Obviously, green energy, which we just mentioned. Almost every one of our sites, I believe we have 15 cement manufacturing facilities in the US, which account for roughly 15–16% of all cement produced in the US yearly. Almost every one of them either has a solar, wind, or hydropower that it's pulling off of, most of which are installed on site, trying to make use of the land that we have available to us. But even with that, we continue to need to go further. So one of the other things that we do is, if you look at waste streams from other manufacturing processes, there's kind of a hierarchy, and I'm sure many of you know this, there's a hierarchy of what to do with those waste products. At this particular plant, tires would be the relevant example. You know, there's the hierarchy goes, obviously avoidance is the ideal, that we really don't want to have any waste products in manufacturing or anything like that. As you go down the chain, the one that we do is a lot of co-processing. So we take materials from other manufacturing processes, and rather than put them in an incinerator or into landfill, we use them in our kilns as an alternative source of energy. One of the benefits of that is that typical incinerators don't get to the temperatures that we do. So we actually break up those materials and burn off a lot of the harmful greenhouse gases that would be generated. So there's another way that we can power our plants with alternative forms of energy rather than, you know, the traditional, which most cement plants have been run off of coal. And obviously that's not the way that we want to be running them, you know, going forward. The next bucket would be green mobility. I think everybody knows this is EV trucks, EV quarry, like loaders and things of that nature, dump trucks that are in a quarry. You know, the challenge there for us is that we've ordered them and they're just not ready for production, or the companies that are making those types of heavy equipment just aren't. They're just too far behind in their production cycle. So we do have a few operating, but again, not quick enough for how aggressive our targets are. And then digitalization, really installing new systems to better understand where our inefficiencies are at our plants. And then green formulation. And this is where I think the folks on this call can really help companies like Wholesome, because as I'll get to later, we can use alternative methods of producing cement, but on the specification side, we really need some help from industry, because what we find more and more often is that we face massive hurdles as a company operating in our own silo to just gaining acceptance of the products that we can produce. So, you know, type 1L, I think, is something that you all have probably come across or heard of. The pushback that we've gotten from industry in our switch to type 1L has been really kind of overwhelming at times, speaking just a little bit frankly there. It's a material that other countries, I mean, even as close as Canada, has been using for decades now and has years of data to support its performance. Yet here in the US, as most cement manufacturers switched over to 1L over the last couple of years, we've had just an incredible amount of angry customers, angry owners saying they want nothing to do with it. And type 1L is a very simple, low-hanging fruit for a cement manufacturer to switch to and really lower their carbon footprint by not a huge amount, but, you know, somewhere in the 8 to 10% range, which is a very good step in the right direction. But I would say that the pushback is going to make cement companies nervous to continue into the next generation of low carbon materials. So, you know, I just, as somebody who cares deeply about this, I encourage everybody to engage at all levels of the folks that you know, work with. And what I mean by that is the general contractors, the concrete subs. That's where some of the biggest pushbacks have come, or even government. I know that, you know, data centers don't necessarily have anything to do with government, but many government agencies have rejected type 1L or made it incredibly challenging to switch over to it. But it's something that Europe and Canada and other parts of the world have used for years and years, and we have plenty of data to support that it's a great product. So anyway, that's just kind of highlighting some of the challenges that we've gone through on what I would call kind of step one of our low carbon movement. And so with that in mind, I kind of want to show a little peek into the future of what I'm talking about with that. You know, step 0 on this is just pulled right out of ASTM specifications. C150 is what almost every data center I have ever been on has specified in their, in their request. And 99% of that has been type 1 or 2 cements, which are the dirtiest types of cements you can possibly make. The reason for that is that the clinker, so in that earlier slide, when we heat the raw materials up, it produces clinker. We take the clinker, we grind it, and that's what makes, that's how we produce cement. So type 1-2 has roughly around 90% clinker, is comprised of about 90% clinker. If you go down to ASTM spec C595, now these have been around for many, many years, but have gained almost zero acceptance in the US. Step 1 is that Portland limestone cement, where we can reduce our clinker factor down to 80 to 85%, which helps greatly with, gives us a roughly 5, 8, 10% CO2 reduction per ton of cement. The next steps beyond that are types 1P, 1S, and 1T. 1S is just simply, you can use type 1L, and then you blend it at the cement factory with slag cement. That takes a bit of investment from the cement companies because we have to add additional grinding capacity on our plants, but it's a byproduct from the steel making process. That's what slag cement is, that we can reuse into our concrete. Now, slag cement is by far the best product available to us as cement manufacturers, and ultimately to you as builders of data centers, because it's very, very reactive on its own and naturally. Many times slag is getting blended at the ready mix production facility. So many of your projects will already have an amount of slag in them, but it's not blended at the cement plant. It's blended at the ready mix production facility. The problem with slag cement is that it's not an infinite product. We can't, we are relying on the steel industry. The types of steel plants that have slag as a byproduct are reducing. So it's something that we want to make the greatest use of right now for an immediate impact, but long term, it's not going to be available. And so that brings into play the type 1P. I think this is really the future of cement production. You can see the clinker factor that we can get to. And what we do with 1P is it's traditional Portland cement blended with pozzolans. And a pozzolan is fly ash, beneficiated ash. There's natural pozzolans out there, volcanic materials, pumice, expanded shale, which is lightweight aggregate. Calcined clays is another one that we can utilize. And these are all regionally based materials. So fly ash is a byproduct of coal burning process. Again, another very limited material, especially as we go further and further away from using coal as a source of energy. And the natural pozzolans, expanded shale, calcined clays, there's really good potential there. They're not nearly as reactive as slag, but you can process them with much less energy intensive processes and still get similar results. So again, the reason I kind of wanted to share this was just to say that we're struggling with type 1L and getting that approved into specifications. that next step with these other materials, even though we have history with them and we can provide data to support it, it's going to be a major lift by the construction industry to get a wide acceptance of those products. And so over the next several months, years, decades, you're gonna see these being proposed on projects, and I just ask that everybody keep an open mind, because it's really the way that we need to go, or we don't have much other meaningful ways to, impact our production processes. And I'll just take a quick pause there. Are there any questions on that? Because after this, I'm kind of gonna get more into the concrete side of it. And I kind of dumped a whole lot of information there, but I don't want to just ramble on if anybody had any questions or thoughts on any of this stuff.
I actually had a few,
Okay,
if you
go
don't mind. So when you're talking about the type 1L and the push, you're saying that people are pushing back, and you're saying they're angry. Why? Like, is it more expensive? What is the main reason, or two, that people are pushing back on 1L?
So it's certainly not more expensive. It's actually a little bit, the material cost is a little bit lower, because you're just taking ground limestone dust, which is one of what you do anyway, and putting it back into the cement after you've dried it. But what it does do, it really becomes a cost offset, because it slows down your production capabilities. So we're producing a bit less, but we're at a slightly lower cost point. So that's not the concern.
Okay.
I think what the problem is, if there's ever any kind of change, it's the construction industry is an old industry, and people like to do what they're comfortable with. And so any kind of change comes with an amount of, well, this is the way we've always done it, so why would we do it anyway, any way different? That's incredibly frustrating, but that's really what I feel. And I think that as problems have popped up, and I would say there have been some problems. I've seen some things where maybe the ready mix producer didn't adjust their admixtures in quite the right way, so there was some issues on a slab here or there. I think there's a certain amount of that, and since people don't like change, the minute they find one problem, even if it's something that's overcomable and that you can fix, they immediately react as, well, I told you so. And then I also think that there's a bit of blame going on. Concrete's not perfect. I'm sure if you've dealt on a project level side, on a site level side, there's always problems with concrete, just like any other product out there. And so I think sometimes the type 1L is getting blamed for what may have been a finishing issue, what may have been the concrete was out of time and you poured it anyway. The concrete got too cold because you didn't protect it in the winter. I think there's a host of issues that come up every year. And when you make a big change, like going from type 1.2 to type 1L, which is a big change, or at least it can be a big change in the mind of the people who are ultimately tasked with placing the concrete and installing it. I think that any problem that then comes up, they blame that as the problem, because they've never used it and it's something different. So that's my own personal opinion. But
when you're looking at all of these different types, what is the longevity of? Is it all the same for all these? And what is the lifespan of a cement slab?
So do you mean from a durability standpoint or an availability of the pozzolans?
Yeah, no, from a durability, like.
Yeah. So
we're talking about replacement, and you're getting into that. So if you're pouring new concrete for a data center, for example, right?
Mm-hmm.
What is the longevity or warranty on how long that's going to be, I don't know if I'm
Yeah, right.
explaining.
Absolutely. No, I understand what you're saying.
And
So,
is there a difference between these different types that would make, somebody
yeah,
think
absolutely.
twice?
Slag is by far the best. In fact, I struggle to understand why when slag is available, we would pour anything with just type 1,2. I think slag cement blended with a type 1,2 or a type 1L is superior to any other product out there on the market. The bonds on a molecular level are incredibly strong. It makes a very long-lasting, durable material. Many.
Oh,
Do we lose Zach?
Did I cut? It says I cut out there. Can you hear me now?
yes, we can hear you.
Yeah, we can.
So yeah, with slag,
Oh no. I think we lost him.
very similar to type 1,2. Your pozzolan cements, there's variability there, and I would say they probably aren't as durable, but that durability can be overcome with admixtures. Because if they're, say, more porous, for example, you just use an admixture that fills in those gaps. The other benefit to these is that
I think you're breaking out again.
Hey, Zach, keep breaking up.
if done correctly, you can do what we call particle packing, where on a very small scale, those fine materials are creating a very, how do I describe it? Creating a very dense product that grades very well together and makes a long-lasting.
Hey, Zach, we don't hear you, Zach.
Materials such as.
You keep cutting in and out, Zach, if you can hear us. Oh,
Hey, Zach. Just as the presentation is getting interesting and the discussion is getting interesting.
yeah.
To go to the concrete production side, this is our internal brand, EcoPact. And again, I would point out that any ready mix producer can do this. You haven't done a data center without.
Hey, Zach, you're cutting out terribly. We can't hear you at all.
Less and less available.
Zach?
Been able to get a source. The opportunity. Can you all hear me now?
Yeah, you are cutting in and out. It's becoming really difficult to hear
Yeah,
you.
mostly cut out.
Yeah. Yeah.
I just don't. I'm at this plant, and I think maybe their internet's not so great. Let me try and move to a different part of the room and see if that helps. If I get closer to the internet source. Is this at
Appreciate
all
you doing
better?
this while you're at a plant. Yeah, you are a little better now. Well,
Okay.
They,
So
as soon as you talk about something interesting, you actually cut out. So it's super super hard on our end.
talk about boring stuff.
No.
All right. Anyway, ash. Ash is a very interesting one because we have tried to make as much use of it as we can, but you know, our operations, for example, in the Mid-Atlantic region, which is Washington, D.C., Virginia, Maryland, that area, you know, in the past 10 years alone, our ability to get ash has dropped by roughly 75%. So that's the challenge going forward with utilizing ash. It's not available, but there is also an opportunity because there are literally billions of tons of what we call ponded ash around the US, which prior to, as somebody mentioned, and I'm sorry I missed your name, prior to the concrete industry and the cement industry using ash, we were just burying it in containment ponds. We now have technologies that have been developed. Wholesome has one of our own, where we can take that ash out of the ground, we can process it. It's called beneficiated ash. Remember that term because it's something you're going to want to put in your specs in the future, because that's a material that we can use and it performs the same as the ash that we've been used to using over the past 20 plus years. So there has been a gradual fall off of the availability of ash, but as we ramp up production on these ponded ash sites, we should start to see more of that coming available in the market. Okay, so EcoPact. EcoPact is Wholesome's brand of low carbon concrete. And again, I just want to point out that there's nothing in EcoPact that any other ready mix producer out there can't do. If you find a ready mix producer that you want to get this type of material out of, odds are Wholesome has a relationship with them and we can help them get to this same type of CO2 reduction. It is a global brand, and for that reason, we typically like to measure our CO2 reductions versus National Ready Mix Concrete Association or NRMCA regional averages. But since it's a global brand and this is sold from the US to Europe to Eastern, everywhere that Wholesome has operations, we have to just base our reductions on this on OPC mixes, which are type 1-2 based mixes, straight Portland mixes. These are available all over the US where we operate. Again, anybody can do them. I think, for me, the positive here is that companies like mine are actually putting out products like this. And so I really encourage anybody on this call that's building anything to engage with, the locals in the area that you're building and ask them what kind of CO2 reductions they can get, because it is out there, it is available. Right now in the US, the two main drivers that we use in EcoPact are slag cement and fly ash. It's something, those two products are easily blendable at the ready mix facility. So that's the easiest way to immediately reduce our carbon impact. So how do we measure that? Again, I think you probably know this, but I don't, I just want to go through it because I think it's important, and I think it's important to encourage companies like Wholesome to do this. I think this is the way that the industry needs to move so that we can understand the impact of what we're doing. All of our plants, whether it's our cement plants or our ready mix concrete plants, have EPDs, environmental product declarations. We follow the product category rules, the PCRs, to develop those. And what that does ultimately is spit out our global warming potential per cubic yard of concrete or ton of cement. That global warming potential is just the measurement that we kind of went over earlier, showing the kilograms of CO2 per metric ton. This says cement, but we do the same for concrete as well. So how do we generate an EPD on the concrete side? First, we have to get the impact of the production of the aggregates, the cement, admixtures, or any other materials that we put in the concrete. Then we measure the transportation costs that it takes to get it to the ready mix production facility, whether it's by dump truck, rail, or barge. Barge is obviously the ideal way, but we don't have a lot of ability to do that. We then measure the amount of electricity, water, and waste generated at the production facility, right there. And then we send it off to the verifier tool. All of our EPDs and all industry EPDs are third-party verified. For us, our program operator is ASTM, so it's a well-known company, industry or entity that we use. I think this is important because it allows you as the owner to understand the impact of what you're buying and what you're putting in the ground. Additionally, it ensures that you're not just taking the manufacturer's word for it, that an outside company or entity has come in and verified and audited all of these processes, all of these calculations to know that what you're getting is accurate. It avoids greenwashing, right? So this is how we generate an EPD. This is the data that we have to collect to put into the verifier tool. So what does that look like? This is an example. I just put side by side what we can do with EcoPact versus a standard straight Portland mix. You can see right here the global warming potential. I kind of think of these as a as a calorie label on the side of any food product that you buy. It shows you the global warming, the kilograms of CO2 per cubic meter of concrete. This is out of our Fort Totten, Washington, D.C. plant. There's your 508 kilograms per meter of concrete. And then here's EcoPact. This is a mix that quite simply just has a lot of slag in it and admixtures to kind of overcome the slow set times that slag can cause. And there you can see. So pretty aggressive reductions. Again, if we go back to kind of what we were talking about before, it's not the long-term solution because slag, we can't just put slag in every yard of concrete that we ship out. There's not enough of it. But we can encourage more use of slag now while we have it available and try and use as much of it as we have. So today and moving forward, again, I just want to reinforce the idea that performance-based concretes needs to accelerate. Those ASTM specs that I shared earlier, that's really where the rubber meets the road. We need more acceptance from industry to use those concretes to allow us to say, don't prescribe how we're going to do it. Let us just guarantee the PSI, the durability, whatever it is you're looking for on your project. Let us as the concrete manufacturer, as the cement manufacturer, guarantee that, and we'll get there, and we'll get there in the greenest way we can, but please don't handcuff us in that process. For us, we're engaging on all levels. We're founding members of the First Movers Coalition. We're involved with a lot of governmental, we're pushing buy green initiatives around the country. I was personally involved in the Buy Clean Act that just passed in Maryland. I think we need to do that. If you look at carbon capture projects, I have 3 in North America and I have 10 or 12 in Europe right now. The reason there's 10 or 12 in Europe is because the regulations that are coming down in Europe are encouraging it. There's monetary assistance to get those projects going. So that's helping to drive it at a much faster rate. I encourage everybody on this call, you all have government affairs people, please continue to ask for those kinds of things when you're out there, just doing what you all do. There's no waste. Everything is an ingredient in something else. We need to, if you're demolishing a building, if you've got waste from some manufacturing process, I'm sure you don't in the data center world, but come talk to us because there's a possibility we could use a material in something we're doing, or other parts of your construction process. Digitalization, I kind of touched on that, but I really think that's going to accelerate all of this stuff. I've seen some really amazing projects that are coming along that are helping to just kind of optimize processes that we have internally and move fast. I believe that that is the key for right now is, don't let objections from a concrete sub stop us from using type 1L on a project in the US. Let's move fast. Let's not wait because it has to get wider acceptance quickly or we will not be able to hit our targets, and I believe neither will any of the companies on this call. And then the last thing I just wanted to share, talking about those hurdles that we have found, the biggest missed opportunity for value creation. This isn't my slide. This is, the World Green Building Council is in that design phase. If there's going to be pushback from specifiers, if there's going to be pushback from your general contractors, your subcontractors, it's a lot easier to overcome that in that design phase than it is a month before or 2 months before the project starts. So I highly encourage anybody on this call, I guess we're doing it today, reach out to companies like Wholesome, reach out to, the materials manufacturers that, I guarantee if you're a company on here that's built a data center, my cement has been in at least one of them, if not more, right? We're too large of a company to have not provided material for some of your projects. And I think the most exciting thing for me is that 5 years ago, 10 years ago, I never would have spoken to any of you. I think the encouraging thing to me in that regard is that now we are beginning to engage. So reach out before a project starts, and a lot of these materials and capabilities are regionally based. So we can kind of help you understand what capabilities cement manufacturers or concrete manufacturers have in a given area, because we operate, so widely across the US and outside of the US as well. And with that, thank you. And we only have a couple more minutes left, but if anybody has any questions, please feel free.
Before we start questions, Zach, thank you so much. This was really, really insightful, and I'm sure we can continue conversations. And then Zach has agreed to participate in our construction working group as well. So I think having his knowledge and expertise there is going to be really valuable for us. Something I was thinking about is what Zach said is like, how can we de-risk using some of these green concretes that Wholesome is proposing or that's available out there. Maybe that's something we can focus on within this working group is provide the differences, provide what the changes are between the concrete, and provide the engineering analysis to show that and those things may be existing already, but maybe that's something we can do in the working group. So just food for thought for you folks out there. I'll open up the floor to questions.
Thank you for a very interesting presentation about a subject I don't really know that much about. I'm doing research now in Sweden and UK, and in my research, I'm interested in the future. So future builds future waste heat reuse and so on. So in Sweden in particular, we have a lot of timber. And a few data centers are using timber frames to lower carbon emissions and also trap CO2. So as a cement and concrete manufacturer, I wonder what your take is on this. Can you sort of cooperate in the future, or will it be one or the other? Or
No, I think timber is a very good way. It's a renewable resource. It's good if you it's something you can use and then plant again and use again. So I'm a supporter of it. As a cement manufacturer, I probably shouldn't say that, but it certainly is something that is more renewable, is a very renewable product. Yeah.
Okay, thanks.
Hey, so we are at time. I'm sure there's a lot more questions, but I will have to end the call right now. So appreciate you all joining, and thank you all for the support. Zach, we can invite Zach back at the next meeting if there are any more questions, but thank you all.
My email address
Have a
is
great
at the
day.
bottom, so if anybody has any questions, feel free to reach out to me directly as well.
Sounds good. Thank you all.
Thank you very
Thank you,
much.
everybody.
Take care,
Thank you.
guys.